Good morning, my super friends. Thank you for coming along. Hang on, I restarted. I've got to turn down the microphone. Yeah, I think that's about right. Okay. While I'm getting myself sorted mentally. All right. First up, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Thank you. Your ears, Scott? Oh, did that fix it? I think that would have fixed it. Yes. Buffer? Buffer. Yeah, ground loop feedback on the mic. It is... Really? Because my YouTube dashboard says excellent connection. Okay. Yeah. I don't actually know. Oh, maybe. Yes, that would be a ground loop. Yeah. The problem was that I plugged in the receiver for the radio mic. It was plugged into USB to charge, and I forgot to unplug it before the stream starts because I need a pre-flight checklist. Otherwise, I don't know what I'm doing. Okay, the list has populated. Good morning to Mr. Fixit, who is currently repairing fire damage in his house and putting stuff up on the... repairing the ceiling right now at this moment, I think. So in audio only mode. Crispian is here, Austin, Gerald42, Sion, so Moo to Sion, Mitchell, Scott Miller, Stephen George, thanks for coming along to the barbecue. Trady Trev, Gavin Jackson, Immy is here, some call it fun, Sharky, David Howes, Stephen W, Russell Rainey, Curtis, Tech Nebulous is back, Michael Wise, James Harris, and looks like Tassie Bob. There will be more people populating the list as the cool little thing updates itself from the chat. Well, this is not good. Maybe there is buffering going on because I have just got a low data rate warning from YouTube. Oh well. Please excuse my cough. Curtis! Good morning, Curtis. And also, oh, and Mike. Mike says, this time last week I was above pit lane at Bathurst detecting illegal drones. Back home now. Mike gets all the fun jobs. Okay, this time last week you're above pit lane at Bathurst. This time yesterday, no, not this time yesterday. 12 o'clock yesterday, I was in the gym with your brother torturing me again. Seems to be one of his favourite things. Why does he start us off with Tabata sets? It sucks. Okay. So, all right. Total squirrel. This is getting... I'm going to get into serious oversharing territory here. Just briefly. But that's because I'm... Yeah, I went from 1080 to 720 and the buffer stopped. Okay. This is going to be such a weird thing to share. But anyway. Have you ever woken up... How do I describe this? Woken up feeling like you're in a stage of grief for no particular reason. That was weird. It happened to me this morning. I woke up sad for like no... I had been asleep. I was deeply asleep. And I woke up and felt like crying for no particular reason. It just happens sometimes. Yeah, brain chemistry is weird. sorry, just looking at the chat. Yeah, Tradie Trev says bad dream. I don't know, maybe, but I just had this. I woke up feeling like I was proceeding through one of the stages of grief, and I don't know why. Scott says, I wake up daily grieving for my lost youth. Maybe that's it. It's like, oh, damn. One day older. One day fewer to enjoy the world and life and all of the interesting things and the things to learn and the things to try. All right. Anyway, that's probably enough of the morbid side of my brain misfiring. Oh, Mitchell says, possible historic memory that was replayed in the dream and it affected you. Mr. Fixit said, yes, old wives invading my dreams lately. Yeah. Okay. There's some fun stuff going on in the chat in relation to Mike's work with drone detection at Bathurst. Oh, Tradie says, we all love you, mate. Hopefully chat will support you. I just had my 40th. Happy birthday, Tradie. Yeah, and I love you too. Mr. Fixit. The problem is there are 4 to choose from. Well, then stop having ex-wives. That's the answer. All right. I missed a whole lot of the start of the stream, of the chat for the stream. Hit the live button to catch up. Oh, okay. Just some of you, I just heard just on chat during the week sometime from Grant, who many of you may remember as Guru of Nothing, one of the mods for the channel for these streams, and he hasn't been around on the streams for quite a while, and I had been wondering what was going on with him, whether he was okay, because he was one of the core team here and disappeared, and every now and then I get an update from him, and he seems to be doing fine. He's just so busy with things. He's been helping his parents out and doing some building stuff, so he hasn't been making it along to the streams. But anyway, I had a brief chat to him during the week, which was really nice to hear from him. So for those of you who have been wondering where Guru of Nothing has been, he has been living life. He just hasn't been living it here with us, which does make me sad. Okay, so for those of you who weren't here at the barbecue last week, something historic happened. Sion came, which was so cool. And so Guru moved to the moon. Hang on, I'll see if this says Scott's comment. TTS. Right.
Scott Miller said, Guru moved to the moon by the look of the pics.
I haven't seen pics. Where has he been posting? Has he been posting in Discord, or is it on Facebook or somewhere? Audio is buzzing, says Amanda. Oh, Amanda is here too. Cool. Tessie Bob, Carden. Sorry, ticking people off the list. All right. Yeah, Sion says we'll not call that historic. It was historic. It was a channel crossover. No, well, Austin says what? No pics of said event. Well, Sion did jump on the stream at the end. He actually got here on camera with me right at the end of the stream. So there is proof that he was here. And for today's stream, I had some options. Okay, Tessie, go to the workshop. We'll just wait here and not say anything until you get there, until you get back. Okay, so go and do what you need to do, and we will be here waiting for you. We crossed the beams, crossed the streams. Yeah. I really need a plan. I need a plan. Yeah, I'm looking to my right because the Testomatic is sitting there. And last week's thing was messing around with firmware. Well, not really firmware, but you know the code that runs on the Raspberry Pi to talk to the peripheral so that we can execute
Scott
tests.
Miller said, Austin, I missed last stream due to turkey coma.
Turkey coma. The best type of coma. Probably the best type of turkey too. Coma turkey. That way they're not attacking you. So the question is, how do we develop code that will run on the test rig that will use the DAC, the ADCs, the I/O expanders, etc., so that we can inject signals into the device under test and we can read signals from it. And my very vague plan, is just to do it all in Python, if possible. But there are some issues with Python support for some of the low-level peripherals for the hardware. And so what we can do is...
Said, best turkey is leftover turkey.
No, but the leftover turkey is turkey that you didn't eat. Ah, okay. It's turkey that you haven't eaten yet. So that does make it the best turkey. Some Call It Fun asked, so are you thinking of some sort of loopback test board? Actually, yes, I am. That's not what I'm talking about, but that is on the plans. That is one of the reasons for these little, these pretty little things. Hang on, not that. Sent you to my browser instead of to the workbench. These things. So this is where's the focus? This is a breakout for the Testomatic with all of the signals. And my plan is to make a board, to design another board that plugs into this one, which might have, for example, LEDs on all of the I/O pins and power rails and stuff, and loopback links so that we can do things like drive one I/O pin and then read it back on a different one. Excuse me. And use that for testing the tester. So that will be my little verification board. But that's not quite what I'm talking about now. What I'm talking about is the software that will run on the tester. Where is the focus? I don't know. I did not prepare very well today. Still too deep in my inexplicable grief. I don't know where it came from. So the run. The question is how to run code on the Pi so that we can talk to all of those peripherals. And Sion offered a solution in our conversation last week. He said I should use Blinker. And since then I have put extensive effort into avoiding researching or doing any preparation so that I would have no idea what I'm talking about when I start this. All I know is that Sion said, check out Blinker. You can see a whole bunch of tabs. Does this give away anything? No, I don't think it does. I'm not doxing myself as long as I don't switch to other tabs. So CircuitPython APIs for non-CircuitPython versions of Python, such as CPython on Linux and MicroPython. Okay. I don't know anything about this, so maybe this is an opportunity to learn. And for you to all shout at the screen and tell me what I'm doing wrong. Scott says, goats are bloody evil. Well, goats are strange. Goats are strange creatures. We used to have 2 goats at my place, up on Mount Dandenong at Kalorama. As well, some of you have been there. So my mum's place is pretty big. It's about 1.25 acres. And yeah, we had goats. Also, back this is totally getting off topic, but anyway, back in the day before things were so organised.
42.
Left, right, 42. Yeah, there is state forest directly behind. So my mum's place can never be encroached on. It has a state forest surrounding it, apart from one side where there is a boundary with a neighbour. And the state forest used to be totally unmaintained, and the previous owner of the house, who was my great uncle before we moved into it, used to kind of farm, I suppose would be the way you would describe it, the state forest. He planted it out there, and kind of not legal, but he maintained that land for like 40 or 50 years, however long it was. So when we moved in, the state forest that was behind, like directly outside our boundary, in fact the boundary fence kind of wasn't even a thing. The property went out, and he'd kind of taken over part of the state forest. Oh, okay, cool. Sion has just provided a link. I will click on that while I am telling this weird story. Just giving you some... Hang on. Oh, that's all right. So, yeah, we had the 1.25 acres or so of legally owned property, plus state forest behind it, which was also being ingested. So pretty big area to maintain on a bit of a slopey, semi-steep block. And when I was a teenager, we had goats. We had a couple of goats out the back, and we we actually had them in the state forest because that was considered part of our garden at the time. We had a goat house out there, which they, yeah. And they, yeah, we'd stake them out. Anyway, goats are strange creatures. That's all I'll say about that. What are we looking at? Okay, using MCP 23008 and 17 with CircuitPython by Tony DeCola, who writes a lot. Many guides. Python computer wiring. All right. Now, the thing is that dealing with the... Okay, so this is how we can do it from within Python. And CircuitPython wiring. Yeah, I don't care about CircuitPython. Python computer wiring. We do it with that. And CircuitPython installation of that. Adafruit CircuitPython. How to install a library bundle. So connect to this. Oh, Python installation. Adafruit Blinker. Okay. Please excuse me while I say random words. Okay, we've already got I2C enabled. Oh, what I need to do is I kind of need to turn this thing on, don't I? Not a lot we can do without it being turned on. I'm going to need a power supply. I'm going to need power cable, which I thought I had. Do I? Yes, I do. I do have a power cable here somewhere. Straight XT60 to XT60. And all right, what do we got? What are we going to give it? 12.5 volts it's set to. Obscure. I think that was because I was charging a battery. 3 amps. That'll do. Okay. There we go. It's spinning up its fan temporarily. We've got power on the display. And pretty soon, oh, and you can see the LEDs on here. Somewhere. There they are. So, the Pi is booting. While the Pi is booting, let's have a look. So, dealing with the 23017 seems to be fine from the... there are binaries anyway that'll already do that. So, we can do it using Blinker and the CircuitPython API. Not necessary, but it's probably a good idea. What I should do is aim for consistency. So whatever method I'm using to access the peripherals, I should use the same method for all of them. Maybe there's no reason for that, but it's just the way my brain works. I like things to be the same. Consistency, repeatability, reproducibility. Oh, a couple more people have turned up in the chat. Dodgy is here. Johnny, my hot Swedish friend. Amanda, I said hello to earlier, I think. Luminator, Paul Schultz. Paul, nice to see you in the chat. All the way from Adelaide. Speaking of Adelaide and Paul, Everything Open is going to be in late January in Adelaide, and so I am going to be over in the great state of South Australia in a couple of months' time. So hopefully it'll be a chance to meet up in person with people who I don't get to see very often, including Paul. Paul, are you coming to Everything Open? I haven't actually booked a ticket yet. I really need to do that. And I've been so burned out the last couple of years that I have not... so there's no Open Hardware Miniconf. We didn't submit one this year. And so I think this is technically... What? Oi! Who rickrolled me? What's going on? Oh, it was Johnny. Okay. Okay. Oh, Paul says I've submitted 2 papers, see what happens. Yeah, Mitchell says, really need to edit the audio. What, to make it longer? What do you want to do? Sion, okay, Sion said, skip to Python installation of MCP 230XX library. Yeah, so I have done at least one miniconf every year since 2003, I think it is. For a couple of years, I ran 2 miniconfs. I did, yeah, like 2 one-day miniconfs, 2 consecutive miniconfs. Stupid. Stupid! Why did I do that to myself? So, the, demonetized, says Sion. Yeah. Bring your Meshtastic nodes, says Paul. Okay. Are you going to be doing some Meshtastic stuff? Is that for in the talk that you proposed? Now, SSH Testomatic at tester 3. Testomatic at tester 3. Let's get some console action happening here. I'll get this up here. Somewhere like that, give or take. And then maybe that can go whoop, there. Whoops, no, there. Oh, look, this is from, this window is here from last time. Oh, I'm going to close that, close that. SM bus, yeah, don't need that. That was from last week as well. So this was what we were messing around with last week. Oh, here it comes. Tassie. Tassie. You really want to get me demonetized? Oh, that was shorter. I think Mitchell has edited it. So Gerald is now a silver supporter. So, and Imi is now has a membership thanks to Tassie Bob's Rickroll. Okay. What's this one? Is this for Gerald becoming a silver supporter? I don't know what's going on. I'm really going to be demonetized, aren't I? Mitchell, what are you doing to me? So we have, yeah, this is what we were using last week. And using the, where are we? Yeah. Here we go. So bus 1, doing I2C detect. Let's just reprise this just to make sure everything is still running. So we're going to do an I2C detect. Now what is disturbing to me about this is that we are seeing addresses 2021, this is all hex of course, 40, 41, 42, and nothing else. That is a real worry because the ADCs and the DAC should be showing up here as devices. 20 and 21 are the IO expanders, and are they? Yes, they are. That's right. So these are the MCP 23017 IO expanders, and 40 through 42 are the INA 260 current and voltage / power sensors. So what we discovered last week is that we can talk to the INAs. Oh no, maybe it was the, yeah, hang on. Yeah, so in this example, he's just got one MCP 23017. So we can do an I2C set. Yeah, so we can set GPI to logic high. Oh, that's right. My memory is... what memory? I do not have a memory. It was not installed at the factory. So this one, that's right, this was using direct register access to do stuff. It was the INA 260s that were working properly. Okay, I'm going to go to projects and CD Testomatic. You can see, yeah, I'm doxing myself as usual. You can see the scripts and stuff that I have in there. Timesheets and timesheet scripts and things. Where? Oh, Any Mules is here as well. Welcome, Any Mules. Test runner classic UI. Huh, there's even a key there. Let's not cat the key. Notes. Okay, to validate. Okay. See, this is why I externalize my memory and don't rely on the the bag of salt
Only RAM
water.
is working. No SSD.
Yeah, only RAM is working, no SSD. Exactly. That's right. So if I power cycle, like if I go to sleep, that's it. It's a I'm running a copy on write file system, and yeah, no persistence through a power cycle. All right. So we validated the INA 260 current sensors. Hey, 1 out of 6. 1 out of 6. 3. What? Oh. Scott says 3 out of 4 APs decided to cook their 2.4 gigahertz radios. What? What's going on, Scott? Scott, done anything? This. Sorry, I'm getting distracted by just flicking my eyes back through the chat to see if there isn't a thing. Okay, I've got to get myself back on track. All right, so we did this. We did the INA 260 stuff, and we can do these things, I believe. So investigate blinker. So here is the note. This is what Sion was saying yesterday. So Adafruit blinker for CircuitPython style access to the 17s from within Python. That pip install, blah, there's some stuff and some other stuff that didn't work. That's right. So pin control is what's working directly. So we can turn on the power. So let's do a very quick recap. We shall. I kind of need myself a second terminal on here, don't I? Let's do this. Let's take that up there and do this. Do another embiggened terminal and that. What's that password? I can't type. Did I get it right? I did. Amazing. Alright, so what we're going to do is basically...
Mitchell R said, audio will drop to around 10-ish seconds within sounding good.
Audio all dropped to around 10-ish seconds. Okay. I see what you're saying. I see. My brain failed to parse that sentence, Mitchell. Sorry. I think what he's saying is that the all of the sound clips have been edited down to 10 seconds. Henrik! Welcome, Henrik. Also, Any Mills. I thought I said hello to Any Mills earlier. And to Jan or Jan? Where am I going with this? Okay, so what I'm doing is let's do a get I don't know, get voltage.py. Let's just try this. So from INA 260, I could just paste this. Importer, controller, C equals controller. Which one do we want to do? So 40 I think is the V-in sensor. So let's do address equals 40. No semicolon. I got to remember. No semicolon. As much as I want a semicolon, I should not do one. And then I'll do print c.voltage. What the hell, let's do current as well. Print See, no, there won't be any. There won't be any. I just want this as a quick thing that I can... let's see what happens if I... Actually, if I just do Python, what am I running? Oh, I don't think you can see. All right, so Python, get voltage. Whoops! Not that. No module. That's because I type real good. And I am sure that you were...
Snaky coding.
I am sure that you were telling me that. Yeah, okay, so 12.28875 volts. We are reading off the V-in, which makes sense. So I'm feeding it, the lab supply is currently set to 12.5 volts, and then it's going through, is it going through a diode? I can't remember. Just wondering why it's less than 12.5. But anyway, 12.28875 is the voltage that we are getting reported. So if I do something like watch that, then we will get repeated voltage readings coming off the V-in rail. Okie dokie. And now, back in here, let's do... So partly what I'm surprised about is the fact that we've got a voltage there at all. Let's let's drive it low and see what happens. Do I have... Oh, hang on, I'm going to switch you over to the overhead camera because we have touchscreen control over those rails. Why am I getting a voltage? I think it must be reading it. Yes. Oh, stupid brain fart moment. It is reading it off the... So if I go V-in on, you might have heard the relay click. V-in off. On, off. So we are reading it before the relay that drives the... So if I do drive high, relay clicks, drive low, relay clicks. So we are reading the voltage before it gets to the relay that controls the power going to the device under test. All right, see, I designed the thing and I don't even know what's going on. So, yeah. Okay, so we've got ourselves voltage readings coming back, and this is doing it out of Python. So what I want to do now is do the blinker stuff and get the 17 working, the MCP. So what do we need to do? Oh, get that out of the way. Get this one back here. And oh, I want that left margin to go away. That's annoying. All right, now, Sion was giving me instructions before and I was ignoring him. Sorry, Sion. Michael says, Python always does my head in without semicolons and indentation without braces. Hi, Twitch. Yeah. Where are we? Yeah, Sion was giving me instructions and I was ignoring them, which means he's probably got sick of trying to help me and given up. I appreciate your help, Sion. Honestly, I do. Okay, so Sion said, skip to Python installation of MCP20 blah library. Python is, so this is where we need to be. So it's saying sudo pip install that, but we may have venv issues here. So, maybe he's just going to do it. That's interesting. All right, hang on. I'm going to mute and take myself a swig, make myself a swig of caffeine. Make Yeah. I called in at Bunnings on the way down here this morning and got another 10 litres of paving paint because yesterday I moved a whole lot more stuff and cleared a whole bunch of space. In fact, I wonder if I've got a photo of it. I vaguely recall taking a photo. Oops. Sorry, I'm just looking at my... Oh, okay, that's done. Okay, I'm just looking at my phone. Oh, yeah. I cleared a fair bit more space. So I'm just going to see if I can...
Glug, glug.
Yeah, that's why I muted. Camera uploads. I'm just syncing Dropbox right now. I hadn't opened Dropbox on my phone since taking the picture. And yes, I know, squirrel chasing squirrel, squirrel, squirrel. Come on, where is the picture? Still syncing. I will let it... Oh, it's getting there. It is getting there. It's just catching up on a whole bunch of photos from the last few days. Here we go. Oh, it moved. Because it's syncing. It moved. The picture moved right as I was clicking on it. Okay, so this. Yeah, all of this space is now empty. For those of you who came to the barbecue, you would know that, well, you can see the fridge here. This fridge is kind of at the back of the area that used to be accessible, and now all of this floor space is cleared. You can see the air conditioner sitting there on top of an old broken bar fridge, which I am probably going to turn into something like a thermal or a maybe like a dehydration chamber, because the fridge in theory should be like it should be a sealed container, and it's insulated. Not that that really matters, but I was thinking of using that as a dehydration chamber to put stuff in and dry it out. All the random stuff. I've got to get the I've got to take the punching bag down and relocate it down towards the back, because what I'm going to do is back behind where everything is sitting. Why is my trackball stop working? Not trackball. Magic trackpad. I can't zoom. So okay. Anyway, down the back, I'm going to set the grappling mats up there. The box, the punching bag's going to move down towards the back, and then this area is going to be for mechanical fabrication. So I'm going to move the baby CNC machine and the drill press that you can just see in the background there. So right there is the drill press. Right there is the CNC machine. And somewhere there's a laser cutter. Where did that go? Oh, that's right, that's moved. Yeah, all of that's the mechanical fabrication stuff. I'm going to put new benches in here and make this like an L-shaped bench. So there'll be a bench running across, dividing this area off from the grappling mats. So there'll be a bench across, a bench down this wall, CNC machine, etc. All the mechanical fab stuff. So that what I can do is have general space in the front where the loading dock is, and then this will be where I can do building type things. Stephen says, and right there in the middle are oil stains from a Honda. Oh, Sion, got to head out. Okay, good luck with whichever way you go to control the ICs. Thanks, Sion. And also, thank you very much for putting in a word for Blinker as well, and telling me that that is the direction that I should investigate. So, yeah, I'm going to do that. No, these actually aren't oil stains from a Honda. You are right. There are oil stains from a Honda, but these are not them. The oil stains from the Honda are not in camera view, and then they've since been painted over, cleaned up and painted over. Now, why am I talking about this? I have no idea. What was I doing? David says there's something missing in that picture. What's missing in the picture? What? What was missing in the picture? I don't get it. Tell me.
Call it fun said. What is the overhead clearance of that area?
Overhead clearance of that area is enough for me to walk under it without bumping my head. I haven't actually, well, I would have measured at some point, but I don't remember. It's, I don't know, like 2.3 meters or something, 2.2, somewhere in that region. I muted just as Scott squirreled. 2.4-ish. Oh, okay. Yeah, so Crispian is... So, outside the box. When I say Crispian, I mean outside the box. For those of you who don't match the two names up. Crispian is fractionally under 2 meters tall. David said, last time I was there wasn't that much unused space, I think, or I'm thinking of a different spot. No, you are absolutely right. There was not that much unused space. I have moved so much stuff to make that space. That's right. The reason for showing you that photo is that I went to Bunnings this morning and bought another 10 litres of paving paint. And part of the job is going to be painting that part of the floor. So painting the floor is a patchwork project that involves clearing space, painting the floor, waiting for it to dry, moving stuff, clearing a different bit of floor, painting that bit of floor. And I'll get there in the end. Eventually all of the parts of the jigsaw puzzle will mesh, and Crispian says, does that qualify me as a 2-yardstick? Yeah, probably. We could measure things in Crispians. So a half Crispian being the metric international standard. American and shorter, yeah. All right, back to here. So we've done this. We've done the pip3 install. That stuff is version 3. You may need to run pip instead. Hang on, maybe... Did I do pip3 install? I did. What did it install? So we've got Blinker, PyFTDI, that'll be for some serial stuff, I guess. That'll be for like, yeah, I don't think we need that, but it looks like it's one of the dependencies that it's pulled in. Adafruit CircuitPython typing? I guess that's probably, ooh, hang on, what have we got? WS28, blah. Yeah, for LEDs, we've got SysB IPC, okay. So for doing like function calls and stuff into the system. Then we've got, oh yeah, we've got the thing we actually care about. And then, where is this? That, okay. Now, back to the instructions. What is it telling us to do? My watch just told me that I haven't done enough steps this hour, and I need to get up and walk. Sorry, watch, I am not going to get up and walk. Not this hour. I am being forced to be sedentary. CircuitPython and Python usage. Okay, so chips digital IO lines from the Python REPL, run the following code. Depending on how we have, that's the blah, that's the thing. For example, on the 17, yeah, 20 will do. Then we're doing, oh yeah, that's for setting the address, don't care. And then we're setting a pin. Toggle the pin. And setting as an input. Read. Yep, true, 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 false. Okay. Sorry, just don't mind me while I skim. Because I have no idea what I'm doing. I'm figuring this out as I go. Import. I'm just wondering whether I should start with this example or start with little simple parts of it and build it up. Initialize the bus, create that. I think this is probably a good... Hang on, so what is it doing there? So it's getting the pins. It is setting that. I think probably starting with this and then what have I got here? Let's go into test runner and I will what I need is, no, I don't need that. What I'm going to do is mkdir will I do it? No, I will do it in test runner. All right. What are we going to call this? Let's do this. Let's call this mcp test.py. Stick this in here and then go back up here and we're going to make a few changes because we want it to be that. We do, okay, so we're initializing that. We want that. And I'm just going to delete a bunch of stuff, but I'll use this as a starting point at least. So pin 1, get pin, pin 0, pin 1, pin 0, switch to output, okay. Pin 1 is an input, pin 0, input, pin 1. Okay, so if we bridge across between the two, if I put it, have a jumper and add or remove it, we can probably see that, and we should see the driving pin 1 being read back into pin, no, driving pin 0 being read back into pin 1. Maybe? Pin 0 value, print state, time sleep, blink pin 0. Yeah, okay. Let's just try it. I think by default this will use address hex 20, but I do want to be specific about this because we have multiple 23017. So I'm going to take the address setting here. Oops. I just want to have a look at the format. So we've got MCP equals that. Okay, so all we do is we've got the I2C object and we just set address. Okay, I'm going to be explicit, even though it'll default to hex 20. And that's probably it. Maybe. Python MCP test. What's it going to do? Is it high level? True, 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 true. All right, so now if I, what am I going to do? I need the breakout. I need to put that breakout into it, and just because I like living dangerously, I'm going to do it while it's hot. Not that it will matter because there is nothing electrical on that breakout at the moment. Michael says, every time you say MCP, I want to say end of line. Yeah, okay, who gets that reference? Do we need an explicit content warning now? Yeah, who gets that movie reference? All right, I'm going to get rid of that. And I've got to move this to where you can see. Right, I'm going to add this, hopefully without causing any particular problems. And so, okay, what we're dealing with is the 17 that is connected to the first batch of I/O pins. And I'm going to grab a pair of tweezers and short between I/O 0 and I/O 1. So we've got this section here where it says digital I/O 3.3 volts. And it's got I/O pins 0 to 23. Pins 0 to 15, no, not 0 to 15, or is it? What am I doing? What am I saying? 24, what have I, anyway, doesn't matter. The first I/O expander is using, yeah, why aren't we using the rest of them? Maybe I'm just wasting I/O pins because there are actually 32. I think it's just because we didn't have enough pins available. Hang on, I've got to cough properly. I'm going to mute myself. And go for water this time, not caffeinated water. Yeah, so 0 through 15 are ports A and B on the first MCP, and ports 16 through 23 is port A on the second MCP. So what I'm going to do is short between pins 0 and 1, and that means that the one pin that is driving the other should be read back in on a loop. So I've just stuck the tweezers into those two pins, and ooh, we can see a change. Okay, now I'm going to switch back to that view. Hi, so that you can see what's coming in on the console. So I'm going to, at the moment the tweezers are not in place, and you can see pin 1 is at a high level is true, and when I short it, it says pin 1 is at a high level is false. And then I'll remove it and it goes true again. Now I'm going to put those tweezers back in place to bind pins 0 and 1 back together. Then let's have a little mess around in this code. Vim MCP test. Let's have a look at what's happening down in this loop. All right, blink pin 0 on and then off. So we turn it on and then we turn it off, and then we read pin 1 and its state. All right, I'm going to make a minor change here. I'm going to turn pin 1 on, and then, sorry, we're going to turn pin 1 on. So drive it high. And then we are going to read pin 1 because I want to see the loop back of one pin going into the other. And then we're going to sleep for half a second, and then we are going to, let's just move this, doink, and stick this here and get rid of that comment. So effectively what we're doing is we are doing a 500 millisecond blink on pin 0, and then we are reading it back in on pin 1. There's no delay in between these two, so this is going to be interesting. There probably should be a slight sleep in between the two, but I don't care because I live for the chaos. Let's see what happens. Oh, look at this. We got true, false, true, false, true, false. So we are driving one of the pins and we are reading that pin on the other pin. We've got ourselves a loopback situation. Trady says, shouldn't the test run for a short time, then output to a file that relates to a serial number? Or am I thinking too far forward? Oh, cough again. No, Trady, you are exactly correct. And in fact, it already does that. Something that I haven't shown you. In fact, I'm Just wondering how much I can show you here, because these testers have actually been in use for a little while now in a limited way. And hang on, I'm going to drag this off the screen because I'm going to open some code and I don't know what I'm about to reveal to you. So I'm going to test runner. So I am going to reveal to you some incredibly embarrassing Python. Because
Ghetto said, "Hello everyone. Just stop in to say hi. My father just passed away today. I'm trying to put myself into work for a while. True, false?"
Wow. DIY. Oh. I'm so sorry to hear that. Whew. That, yeah. I mean, I have no idea what your relationship with your father is, but no matter what it was, I'm sure that is a rough situation to be in. So, yeah, I'm really sorry to hear that. I hope you're okay. Just based on what you said there, so I'm trying to put myself into work for a while. It sounds like you're trying to distract yourself. All right, so given that I think you're trying to distract yourself, I am not going to say much more about that. Just, yeah, as Imi says, look after yourself, spend time with your support network. That's good advice from Imi. And maybe we can be part of your support network as well. If us distracting you is helpful, then we will do our best. Yeah, we'll do what little we can.
D in the Ghetto said, "Sorry for being a bummer. My dad is my best friend."
Yeah. And as Mitchell says, hugs. So I hope you're okay. Let's engage distraction mode and see if we can get you into a different state of
Squirrel.
mind, help you deal with it. Yes, squirrel. We will be your squirrels, DIY. Yeah. And Scott says,
Miller said, "Squirrels fur DIY."
yeah. And DIY says I'm okay. That's good. Well, with that in mind, let's have a little bit of comedy, and I will show you.
This might answer your question.
Alexa, stop.
I know about
And I will show you a little bit of of Python that is what currently is the test runner. But just before I open that, I'm just going to have a look in targets. What can I show you in targets? How about, I think this one will be okay. Upload. Yeah, targets, target.ini. Hang on, MCM. This is kind of getting ahead of ourselves a little bit, but we will come back to this in, yeah, we will come back to this, but I'll show you this just as an example of the prototyping that I've been doing before the real thing happens. All right, so what we have at the moment is several things. There is a thing called test runner, and if we have a look at test runner, which is my horrible Python, where are we? You can see here there is a whole bunch of stuff that is hard-coded that really should not be. This is my proof of concept. I keep putting disclaimers on this. It's because I'm embarrassed. So we've got a path prefix here of home test-o-matic test runner, and this really should be dynamically generated. but at the moment it assumes that you are running as the test-o-matic user in this location. And this script is called with some arguments passed to it. So it is told the SKU of the target that it is about to test, and it is told the serial number of the target that it is about to test. And this comes through as a single argument with dashes separating it, partly because this is actually invoked, this script, this Python, is invoked by Node-RED. I won't get into the details of that. We're going to get to all of this in future. We're going to rewrite it and we're going to make it pretty, I promise. So we know the SKU of the target, we know the serial of the target. And at the moment, it's hard-coded as to who did the testing, which it shouldn't be.
Python is embarrassing.
But it is. So we've got some commented out stuff there from when I was doing testing. So we get the device under test directory. So we've got the path prefix, and then I will show you this in a second. There is a directory called targets, and then then we get a timestamp, which we're going to use later. We look for a reports directory. So remember, the targets directory, the reports directory. We will use those shortly. Then we define an output file that we're going to use for printing, and that goes into reports, subdirectory for the target.
Working software beats pretty software.
Yeah, and this kind of works. We've got timestamps and all that sort of stuff. Manual checks. There's a manual checks file in the device under test directory, and there's a config file from the device under test called target.ini. You will see all of this in just a moment. The goal of this, the whole idea with this, is that this test runner code should not need to know anything about the device you're testing.
Austin's_creations said, code it to your hand as the user, aka RFID.
Yes, code it to your hand as a user. Yeah, so I've got to stick my arm near the tester. It reads the RFID chip and then identifies me. Yeah, I could do that. That can be one of the devices that plugs in on the spare USB ports. So we parse the config file. So I've got a, you will see that in a moment as well. Then it gets out of it, it sets a few things. So the client name, the device under test name, hardware version, firmware version, test version, because you might update your tests. And so if you want to look back at test results, you want to know what version of the tests were run against that particular target. So you might have no change to hardware, no change to firmware, but you've changed your tests to include something new or whatever. So the test version has to be tracked as well. And then we've got options for enabling the receipt printer, whether we take a photo of the board, whether we install firmware. By default, they are all true, but they can be overridden on a case-by-case basis. And then we open the, this is the header for the report file that comes out of the receipt printer. And you can see it's just substituting a bunch of stuff, timestamps, etc. Automatic check, so it checks whether it's meant to install firmware. If it is, it tells you it is, and it sticks it into the receipt printer. And then it gets the command, command output is the response from doing an OS call. So it does os.popen, so that is a call out to the operating system to fork a new process and execute upload.sh. What else do we do? Blah, print that, we print the output. Manual checks. Okay, it loads a manual checks file and sticks that in there, which you will also see in a moment. Then it sticks the, test version. This is from when I hard coded all of this. So what happened was I started writing this as a version that was hard coded to test one board, and then I began abstracting out the different parts of it so that they would not need to be, so they could be included in the target profile. So we've got test version, which now comes out of the target definition. It generates a URL dynamically, so d.superlab.au, and then the serial number, and test end closes the file. P.close is, so P is the
So much
file
bubble,
we're going to print.
so much wow, so much Doge.
We Doge to please. So it checks if it needs to print the receipt, and it looks for the receipt printer, which at the moment is hard-coded as this printer ID, but that should be a configurable thing in future. And if the photo is enabled, then it sets the target for where it's going to save it. It calls FS webcam, sets the resolution, and takes the photo. Once again, forks a os.system photo command and calls that out, which takes the photo with the webcam and stores it into the target directory with the timestamp and everything. And that's it. That is all it does. So what we've then got is, if we have a look in targets, actually I'm going to CD into targets. I'm going to show you one specific target definition. And the idea is that for each board that you want to test, you have one of these folders, which defines everything you need to know about how to test that board. And at the moment, it has the target.ini. So let's have a look at target.ini, which is the definition, basically the initialization file that specifies what we're doing. And we've got a couple of major config blocks in this file. DUT is device under test, and these, the values that are in device under test have to be there. They're obligatory. So test version, that says what the version of the test was, and I've just been using a date. The hardware version for this target, the firmware version for this target, the name. Yeah, and for those of you wondering, yes, it is okay for me to be showing you this for T-Rex. So I have discussed this actually fairly recently with Simon from T-Rex, and he's okay with me showing you stuff. Not everything, but certain things. So this is for the water cannon system. So T-Rex water trucks, MCM is the monitor control module, Mark II, and that is the device under test name. Then we've got the client name is in there because the client name gets added to the report, the test report, and firmware flasher. So this tells it where to find the script to execute the firmware upload. And then we've got overrides. So these don't need to be included. I could delete this entire section and it would work fine, and the test runner would run, but this allows us to override. So enable printer, enable photo, and install firmware can be overridden on a per target basis. And I want to have that configurable from the UI as well. Then we've got, I'll just show you the upload. The upload script can be anything you like. You've specified the path to this. In this particular case, it's calling out to ESP-tool, which is a Python thing, yeah, oh yeah, that's just commented out. So that's right, that was the old way of doing it. This is the new way of doing it, calling to user bin ESP-tool, just because the installation location changed. Anyway, it's configured with the port. Once again, this should be configurable from the UI, but it's not yet. It's all hard-coded in this script. And it's just got whatever arguments you want. It's got the hex locations for the binaries that need to be loaded into Flash, the path to the binary for each of those chunks of Flash memory. And so this script can be anything you like. It could be calling, I don't know, in this case I'm calling ESP-tool, but it could be calling AVRDude if you were flashing an AT Mega, or it could be, you know, doing UPDI uploads or whatever. That it's just upload.sh. And even that's arbitrary. You could make the upload script anything you like because it's specified in the target. Then we've got, there's a test file which is empty in this case. You can see the file size is 0, but that is a script for executing tests, and that is the entry point for what we have been playing around with today. It is like what I need to do is hook into this framework the way to execute these tests, like drive pins, read from pins, etc. Then we have a manual checks text file, and this one is for a human Q&A assessment. And what happens is that this simply gets inserted into the test receipt. So when it comes out of the printer, it's got the header with the information about the board serial number, date it was tested, all of that sort of stuff, and automatic tests, the results of automatic tests. But it just takes this chunk of text and plonks it into the output that comes out of the receipt printer. And that means that the person who is doing this has in front of them a printed list of things that they need to do and tick off. So in this particular case, is the serial number on the back of the PCB? Yes. Is the CAN termination header not fitted? Because this is something that we do not want to put on the board, and we just want to make sure that no, it has not been soldered on because we don't want it. So has the CAN termination header not been fitted? Tick. Has the VCAL header not been fitted? Tick. Has the yellow eValve header been fitted? Tick. So this is just something that you go through, and there are certain things that can't be checked automatically, like has the CAN terminal not been fitted? And in this case, like piezo beeps at startup. When you power it up, you hear it go beep beep, and then you go, yes, I know, that works. But the goal is going to be to replace, and things like a reminder, put a desiccant pack, like one of those little desiccant dry packs, in the bag with it. So it's a reminder to the person that is doing the testing and packing that they need to do all of these things. So that's very simple. You can just arbitrarily edit that text file, and whatever you set it to, that is what's going to come out on the receipt printer that go for the thing that goes in the bag. Okay, so that is how the tests are. Oh, and releases. That's just where the binaries are stored for the different things. Okay, so now let's have a look in reports. Hang on. Why? Oh, I know why. I'm on the wrong machine. I was wondering why there weren't reports. Actually, no, that's all right. I can show you some CAN board reports on this. I thought there'd be MCM reports, but I'm on tester 3, and most of the time we use tester 2. So, CD CAN board. What have we got here? Okay, so what we can do is say so 2692 is the serial number of the device under test. So it's sorted by serial number. CAN board is the SKU. This is the timestamp of when the test was executed. And if we have a look at that, we can see that it was done on that date, that was the thing, etc. So there is that text file which is stored and timestamped. And if there had been a photo taken at the same time, it would have been stored in the same directory with the same timestamp, so you can match them together. There needs to actually be a better way of binding multiple assets together into one test set, like test result set. But for now, it's just done based on timestamp. But the photos weren't being taken. Some Call It Fun says, not coding in prod, are we? Oh, okay. Austin says, might actually be a cool idea to put a thermal camera on the test rig, flag any abnormal temps. Yes, that's exactly, yeah. In fact, we were doing that. It's the little thermal camera module is right over here. This is something I need to get back to. This is the thermal camera module that we were playing around with. When was this? A month or two ago? Plugged into a Raspberry Pi a couple of months ago. Yeah, and we got data out of it. That's right, it was on the day of it was 2 barbecues ago, which means it was 2 months ago. Because it was, well, 2 months and a week. It was after that barbecue that a bunch of people came around, like stood around my desk and told me what to do, and we figured out the data. We got the format of the thermal data coming out of the camera. Yeah, so I want to store both RGB images and thermal images, and I also, in the data that comes off the thermal camera, essentially what you end up with is an array of values of temperatures. So just like with a normal camera, you have an array of pixels, and the pixels typically have RGB values. With a thermal camera, you get an array of pixels, but each pixel is a temperature. So it makes it easy to do things like set boundary conditions, like is the board going above a certain temperature at any location, because you just find the highest value in the array. Yeah, all of that sort of stuff. That's pretty easy once we get that data coming in. But that is something to return to. Anyway, so this was all yeah, okay, so this was all a squirrel chasing thing, but just showing you some of the context of what's going on here. So the thing is that I already have this running. I'm already using these test systems in production for customer boards, but the automatic tests running through the breakouts are not working yet. The things like firmware uploads through the pogo pins onto the target board, that works. But the like with this, for example, I can flash customer boards with this. There's the USB to serial converter on the back that does the programming. That's an ESP flash module. And with this, where's the header? Somewhere. Anyway, with this, I can put a customer board onto this, run test runner, and it'll flash the firmware onto it and print me out a test receipt. But I need to be able to run the automatic tests through those I/O pins. So that gives you context. It is already a functional system. It's just not fully functional. It doesn't do everything. The shape of it is there, but the detail is not. So where do I want to be? Oh yeah, there. Is it there? Yeah, MCP test.py. That's right. That's what I was messing around with. Back to here. All right. Hang on. I need to make some notes. Otherwise, I'm going to totally lose track of what I'm doing, what I have done. So, yeah, we still got our little voltage thing updating every 2 seconds there. Now, oh, no, it's not there. Wrong directory. Wrong direct or E. Okay, this. Not even the wrong directory. It was the wrong machine. Totally the wrong machine. All right, so this, I am going to get rid of all of these notes, and I am going to put in this, and where are we? Go to, what section was I on? It was CircuitPython and Python usage, easy installation, like CircuitPython, Python, here we go. Go to that. Oh, that's what I should do. Just copy the link with the anchor in it. That would be a far superior idea. Oh, hang on. Why didn't... Oh, I know why. because I needed to do that. I don't know how to drive this. I want to mark that, get rid of that. Hopeless, hopeless. I'll get there eventually. There. Now my notes will start to make a bit more sense. Oh, okay. What's going on? This. So, what was it? MCP test. Created a test script called MCP test.py. That's just a reminder to myself that that file is there. So, actually, let's go back into here. What else are we doing? Oh, it was MCP, it wasn't underscore test. It was MCP test. MCP hyphen test. Then, okay, what else do we need to know? What do we need to know? We now know that we can read and we can write the I/O pins. What other useful commands? So we've got that. I want to have a look at pull-ups and pull-downs, what I can do there. Direction output, true, false, where is the... Here we go, pull. Okay, so we can do things like this. I'm just going to make a note about that. Pull-ups. That'll do. Digital IO dot pin one dot direction, digital IO direction input, and digital IO pull dot up, and presumably we can do a pull dot down because I'm pretty sure that the MCPs have both pull up and pull down resistors internally, so we can set that as a pull down. Yes, Tradie is correct. Talking to the MCP over I2C. Michael says, well, technically wrong machine still means wrong directory. Yes, it's just more wrong. The wrongest. Wrong directory, wrong file system, wrong CPU. Sorry, I'm pausing because I'm kind of lost about what to do next. Okay, we've now... Let's do a recap. Well, not a recap. Let's just add this up here. I'm going to mark MCPs as being not OX, as being okay, because we can now talk to them. We can read inputs, we can write outputs, we can set pull-ups. So, that is solved. That is using Blinker, and the current sensors was done, I can't even remember. Where are we? Oh, okay, no, the current sensors are supported directly. We don't need to use Blinker for that. There's the INA260 driver here, so we can just create a controller object. Okay, so that is using library. So the things we need to figure out now are the MCP4728 DAC and the ADS 1115 ADCs, which do not appear to be showing up on the bus, and also the EPROMs. Let's have a look. Scott says, I can be logged into any of my desktop machines and get the same data no matter which directory under my own home I go to. Yeah, so you got directory, you got sync happening somehow. How are you doing it? I'm curious, Scott. Some Call It Fun said, that is, the test board was going to have an identifier of some sort. Yes, it does. That's the EPROM. If I come back to the notes, you can see there are two EPROMs. Oh, whoop! What did I do? I don't know how I did that. I was trying to do zoom in on the terminal, but I somehow opened help for iTerm. So there are two EPROMs. They're both Cat24C32 EPROMs, which are the ones that are typically used for Raspberry Pi hats. This one is on, in fact, I'm going to add this to the notes, on I2C bus 0, which is only enabled at initialization. And then we've got on I2C bus 1. So bus 1 is the one that we are using for the current sensors and for the I/O expanders. Bus 0 is reserved by the Raspberry Pi OS, and it's initialized during startup to read from the HAT EPROM to identify what peripherals it might need to initialize. So, and I believe that is not dependent on the setting in Raspi config about whether I2C is enabled. But this one, bus 1, this one does depend on I2C being enabled. So, in fact, what I'm going to do is move that to the bottom, because that is on bus 0, which is different to the rest. It is not like the rest of the things. All of these, down to this point, are on bus 1. So to follow up that comment from the chat a moment ago, the idea here is that this EPROM is installed on the Testomatic PCB that is in the tester, and we can use that to tell the Raspberry Pi that it is a Testomatic at startup. And then this one, which is the same type of chip, is on the test module. So this test module down here in the corner has an EPROM on it, and that is to allow the test module to be identified when it is plugged in. But we have not validated either of these yet, and we have not validated either of these. Ooh, I just had an idea. What am I going to do? Come back to, there. I am going to remove that. I'm going to remove the breakout PCB, and I'm going to stick this test module back in. Yeah, hot plug, probably not a great idea, but anyway, screw it, I'm doing it. Oh, there we go. Okay, so you can see the LEDs are on here for the test module. We've got the 3.3 volt, which is blue, we've got the 5 volt, which is red, and the EPROM is just to the left of those LEDs. That is the EPROM that identifies the test module. And that EPROM should now be on the I2C bus. Because I hot plugged it, maybe we need to reinitialize the bus, maybe we need to reboot, I don't know. But if we come back to whichever terminal I was doing it in, probably this one, maybe this one. Let's do sudo I2C, no, not set, I2C detect bus 1. Here we go. Clear. Let's do that again. So what we should be seeing here is the EEPROM being identified on the I2C bus, as well as the DAC, etc. Could we test a really bad board with a fault? Says Tradie Trev. I want to see flames. Okay, so... Oh, okay. Scott says, I run SyncThing for my laptops. SyncThing is excellent, concurs Michael. SyncThing makes Dropbox
Peter
look like a bad joke.
Combos.
Yeah, I use Dropbox and it is incredibly helpful, but I really should... Yes, we should blow on the cartridge connector, Mike. I should look at SyncThing instead. I've heard very good things about SyncThing. Oh, what am I doing? Okay, I'm going to risk it all, go for gold, and open Fusion. Peter Lawler says Nextcloud, because I want to remind myself, sorry, Fusion is just taking a while to open. I want to remind myself what is going on this I2C bus, so that we can see why we can't see the ADC or the DAC. Testomatic 212121. This will do. This PCB is not exactly the same as the one that we're looking at now. This has some changes applied to it, but it'll be enough for our purposes. What am I doing? Yes. Maintenance. All right, so this is the... Which one is this? This is the hat EEPROM. So this is on IO0 and IO1. Those are the pins reserved for the hat EEPROM. Raspberry Pi header, so they go to IO0, IO1, wherever they are. Raspberry Pi header. Let's find them. There, IO0 and IO1. Then we should have SDA and SCL for bus 1. Here we go.
Peter Lawler said Proxmix, Home Assistant, Nextcloud, and OpenSense FTW.
Proxmox, Home Assistant, Nextcloud, OpenSense. Yeah, good combination. All right, so we've got I2C bus going through this level shifter to a 5-volt thing. So maybe the level shifters are the issue. I don't know. We've got I2C being exposed up onto that. And then what else do we have? Okay, so we know that these are working, the INA 260s. So we've got SDA and SCL going to those, and that is at 3.3 volts. So maybe that is the issue, because the INAs are direct connected 3.3 volt devices onto the bus.
Scott Miller said Proxmix, 80 or so LXCs running everything under the sun PF sets.
People are comparing home setups now. All right, so we know those are working. That's good. The MCPs are working. All right, we know those are good. Those are also on, directly connected to I2C. Now, the ones that are not working, okay, this is very, very interesting. I have a feeling that my level shifters are not working. That's why we can't see the ADCs or the DAC. Because look at this. These are on SCL 5 volts and SDA 5 volts. Hang on. Where's the show? There. Highlight that net. So SCL 5 volts these 3 devices are all on that net. What else is on that net, if anything? Maybe that's our USB hub, which is working. I believe we have determined that's working. So I think my problem is around here. It's these I2C level shifters, SEL 5 volts, SDA 5 volts. What have I got? Have I done something dumb like put these transistors backwards? I probably have. What have I got? 7002. So we've got the, I can stick the scope on this and see if we're getting SEL signal on the 5 volt rail, like the 5 volt version of the clock signal. Some Call It Fun says, Tron, get the logic probe. Yeah. Okay, this is actually a little reassuring because having no result on this for those devices is kind of disturbing. But the fact that all of the devices that are on the 5 volt version of the I2C bus have failed kind of localizes the failure to this area. Now let's have a look at MOSFET level shifter. Well, look, let's see if I have screwed this circuit up, which I probably have. I'm just going to try to move that. How can I move that so that we can see the other thing at the same time? LV, HV. All right, I want that. Then I want that. And I want to move this over there. Okay. Oh, and my stupid face is in the way. So let's move that to there. Move that to there. All right, what have we got? The LV side, 3V3. We've got a MOSFET with gate, source, drain. We got the high voltage side pulled up weekly, well, semi-weekly to 5 volts. And then we've got the SEL 5 volt rail coming off there. I should check that that there is no net split happening and that this net really is connected all the way through. Because if there was, if they were on their own net segment, that would be embarrassing. Also very easy to fix because I could just patch it with a jumper. R3 and R4 are switched. Oh no, Mike. Yeah, Don said need a test-o-matic for the test-o-matic. That is correct. I do actually need some level of self-testing. That's why I want that loopback breakout to go into to plug into the chassis and test whether the test-o-matic board is working. You should be able to run a self-test. Yeah, swap the designators. That'll fix it. That looks correct to me. Apart from the fact that I'm using a 7002 and the example is using a BSS 138, but they're functionally equivalent transistors, so that doesn't fall into the care factor. I do not, just at a quick glance, I do not see why this is not working. All right, what I'm going to do is bring this down here, and I'm going to split out the PCB into a separate window and bring it up where you can see it, and we're going to do some net highlights. Oops, I want that. And just to remove some of the visual noise, let's do that. Oi, hang on. That's what I was trying to do. And then we'll get rid of, how about we just get rid of that? And now what I can do is down in the other window that you can't see.
Peter Lawler said, your face is a care factor.
I'll care factor your face, Peter. Oh, care factor it good. So this highlighted net.
Peter Lawler said, "Your face is a care factor."
I thought we already did that one. This highlighted net should be the 5-volt version of the clock line coming off the drain of the level shifting MOSFET. So let's have a look at this. There's not much on this. It's just these devices on that net. So what is going on here? Why are none of the 5-volt devices working? Now, part of this could be an assembly fault. It could well be. Now, in the time remaining, I'm not going to be able to solve this because the PCB that this is all on is screwed inside the chassis. To get it out, to get access to any of this to do diagnosis, I am going to have to partly disassemble the chassis of the Testomatic. And that's not so easy. Well, it's not hard, but it just takes a little bit of time. It's a little bit fiddly.
Factory.
Care Factory. Was that Peter? Who said that? Who said Care Factory? Where's the chat? I can't even see the chat. I've covered it with Windows. Say Q. Care Mr. Fixit says, "This is better than listening to audio books while I work. Good company and informative too." Well, thank you, Mr. Fixit. Yes, Peter, your face is an assembly fault. Austin says, TTS will catch up in a second. 3-layer also.
Austin's _creations said, "I can almost never get transistor shifters to work on I2C. Might be better off with proper IC."
Yeah, that is true. So maybe it is just that like the clock speed is too high for level shifters, and so I have done this many times before. I've used this MOSFET based level shifter. Excuse me, gentle folk. I have used this MOSFET based level shifter approach on I2C many times in the past, and it has worked, but it could be related to the bus speed. Normally I'm doing this off a microcontroller, not off a Raspberry Pi, so it's possible that the bus is being initialized at a higher clock speed, and so what we're getting is a bit of smearing, a bit of signal degradation, because we are running through these level shifters. Sometimes you can fix that by making the pull-ups stronger, which helps with the edge transitions. It makes the transitions faster, so you get a more square sort of signal. And I've only got 10K, these are 10K pull-ups on both the high and low side. In fact, why is there a 10K there? Isn't there already a pull-up on the low side? I think I've doubled up my I2C pull-ups. Have I? Haven't I? Or am I just relying on the 10K pull-ups? It might actually be worthwhile to change the values on these pull-ups, because 10K is kind of weak for an I2C pull-up. Should be 4K7 by default, and you can go lower. I did a project fairly recently for a client where we needed, for certain circumstances, to run I2C across many meters, and we ended up with I2C working fine at around 12 to 14 meters of cable, and we were running 1.5K, I think it was, might have even been 1.1K pull-ups, and yeah, because of the capacitance on it. And we dropped the bus speed and all sorts of other things as well to make it work. but it actually worked. Like we got I2C working, and this is in a noisy environment. This is with solenoids, like a semi-industrial thing, with electrical noise around it, and we got I2C working. So, but we needed strong pull-ups to make it work, and I could see the effect on the scope. I was looking at the signal to see whether we're getting degradation, and we definitely were. It wasn't working at all initially, and then we started messing around with things. Also, the other thing I did was I put in I2C line driver chips, like proper line buffer amplifiers. So the devices had, and repeaters. It wasn't like a single segment of 12 meters. It was segments of a couple of meters and then an I2C redriver IC. Anyway, this right here is where I need to cast my eye and figure out whether we are getting anything on clock and data on the 5-volt side. The problem is, or is that exposed? I don't think it's exposed.
Austin's_creations said, for distance and noise I like using the LTC 4311.
LTC 4311. Is that the same one that you recommended a while ago for hot swap support? Because that is on my list of things to investigate. I do want to be able to hot swap those test modules, which means that I want I2C hot swap. LTC, hang on, where's the chat? I've got to get that part number again. Austin said LTC 4311. LTC 4311. Low voltage I2C SM bus accelerator. Okay, I2C extender. Active terminator. This might even be the one that I used. Hang on, I'm going to... Now this sadly is in a client project, so I can't show it to you, but I am just going to check. I'm going to have a look. I might be able to show you just that part of the schematic. I've just got to find where the project is. It is there, this. Okay, this will open on my other monitor so you won't see it. I'm just going to find the part of the schematic that has the I2C redriver on it.
Austin's_creations said TCA 4307 is for hot swap. It is used on the OXRS Blackworks Grey.
Ah, okay. Cool. No, actually it was a different chip. I need to start taking some notes from you, Austin. Alright, I'm going to show you just this portion, which is 1K5 was what we ended up at. Look, there's nothing here. No, it doesn't even have the customer name or anything. There's no identifying stuff in here. So this is what I ended up with on the module. So these are modules that are daisy chained at a couple of meter increments. So we've got a line coming in here, and then it goes out to the next device in the chain.
Peter Lawler said, notes are overrated.
No, notes are highly underrated. So what I used was a PCA 9508, which is an I2C redriver chip. So you bring in SEL and SDA on one side, on side A, and it drives it out on side B. And it can also do voltage conversion. So you've got the voltage on one side and the voltage on the other. In this particular case, I'm driving 5 volts on both sides. So it is just receiving the I2C signal in on the left, and then it is redriving it on the right, going out down another few meters of wire to the next device in the chain. But that was using the PCA 9508. So I am interested to see, I'm going to go back to here, there. I'm interested to see what this thing does. Extender and active terminator. Cool. Right, don't need any of that. That is what I want. DigiKey. Key your digits into this search box and we shall see what we find. Okay. Signal buffers, repeaters, splitters. WDFN, TSSOP, whichever. Let's have a look at this. $9? What? What the? That is an expensive little part. What is it in quantity? It's still, even at like 100 up, it's $4.65. Okay. I'm sure it's good, but that is an expensive little part. All right, now, Austin, what was the one you're talking about for the... where... TCA, okay. TCA 4307. This is the hot swap driver. Hot swap controllers, PMIX. All right, stuff the QFN. Let's go for something that is much nicer to work with. Yeah, still not cheap, but not $10 a chip. All right, so what have we got here? This one is a hot swap controller. How do we use it? How do we use it? With stuck bus recovery. Cool. Supports bidirectional data transfer. Does this also do level shifting if that's what we want? So we've got, oh no, it's only got a single VCC. So there's no level shifting involved. It's just a hot swap isolation doovalaki. So we've got clock out, SDA out, clock in, SDA in. What? Why are they... Just looking at the pin assignment there, wondering why that makes sense. Clock out, clock in, yeah, I suppose it kind of makes sense. Yeah, I would have expected it more to be like a pass-through. SCL and SDA on one side, SCL and SDA on the other. Not a problem.
Said, Austin probably gets his from LCSC.
Yeah, probably. I tend to look things up first on DigiKey because availability is more guaranteed, typically. It's a worst case, it's a worst case price. So if LCSC is out of stock and I have to buy stuff from DigiKey, I want to know what the DigiKey price is. Ooh, I'm getting messages from Guru of Nothing. With pictures apparently. I don't have Discord open, I've just got the notification coming up. So we've got, what was I talking about? Yeah, that's right, anyway. So I kind of treat it as like a worst case scenario. So I start with DigiKey, and if I see a price on something that is quantity 100, $2.49, then I kind of mentally account for that as being the cost of that part. Now, it may well be that I can get the same part for 50 cents from LCSC.
Said, time for lunch.
It is actually. But if LCSC happen to not have them or whatever, I don't want to be stuck in a situation where I have factored in the cost of the LCSC price and then discover that I need 100 of these and now I've got to pay the DigiKey price, like pay the iron price, and I haven't allowed for it. So yeah, I kind of allow for a worst case scenario being the DigiKey price with fast shipping, etc. I know I can get them in a couple of days, and yeah. So, oh, Tradie said, didn't Great Scott do a video recently on I23, which is, no, isn't it called I3C? It's the successor to I2C, is now called I3C. Yes. Yeah. Oh, Scott says I should check Guru's pics. All right. I will. Hang on. I'm going to, when I open Discord, I do not know where it is going to open. So I'm going to subject yourself.
Check Guru's pics.
I'm going to subject you to my face while I open his pics. Ooh. Okay. Cool. Let's open that.
Scott Miller said, you should check Guru's pics.
I am. I am checking his pics right now, and I am opening in a browser window so that in a second I can bring it up and hide my face, hide my shame. Here come the construction pics. All right, so this is what Grant has been working on. Big construction. That is kind of epic construction. And here's another view. Oh, look, there are solar panels, what looks like solar panels on the back of a truck down there. Is it a truck? I think it's a truck. Yes. Those look like tail lights and wheels, etc. So portable solar panels sitting on a truck. What's down the side there? Batteries maybe? Not sure. But in any case, that is kind of epic construction. And this is on the inside. So there is some framing going up, insulation in place. That is a, yeah, okay. We can't read anything
Scott Miller said,
on those signs.
Move to the moon.
I was just looking at this. I see. So this is plasterboard, or what you Americans would call drywall. So there is a stack of drywall leaning against the framework there. There's a whole lot of sheets of it ready to be put up. Yeah, that's impressive. Nice work, Grant. Actually, I don't think Grant is here in the, the stream right now. He's just been messaging on Discord. Oh, Scott says, it's a repurposed trailer with concrete blocks for wind protection. Ah, right. Yes. Yeah, because the panels, where are we? It's like a big sail. There would be a lot of wind loading on this. If you got a bit of wind coming down that valley, catching those solar panels, then yes, the wind would come down here from the right, hook under here, try to flip the trailer over. So these are concrete blocks tied to the side of the trailer to hold it down. Yeah. But where is the wet wall? Asked Henrik. Yeah. Dry wall versus wet wall. Okay. Yeah, so with plasterboard, you can get wet area plasterboard, which is designed to withstand moisture in areas like bathrooms. So we call it plasterboard and wet area plasterboard. So do Americans call it drywall and wet wall, or drywall and wet drywall? I don't know. Oh, Scott says, I'm relaying your reactions to him. Yeah, cool. Yes. Well, I hope you convey to him that I am impressed. This is a very serious construction project. Yeah. Okay. I'm I am going to go, but before I do, extender active terminator, let's skip that one. I want to have a look at the, no, not that, this hot swappable, the 4307, yes, this. So this is probably what I need to add in. In fact, what I should do is go into, where is the testomatic schematic, to do. It's already in my notes. Check this out. Hang on, I'm going to close that to prevent another little docs. Okay, these are my notes for future revisions. And one of them is, make the breakout hot pluggable TCA 4307. Thanks, Austin. That was already in my notes. All right, so what I need to do is, oh, look, what else was in my notes? See, this is why notes matter. My memory was blanked. It says, check if 10K I2C pull-up is strong enough. That may well be my problem. So what I need to do is disassemble the testomatic, get the PCB out on the bench running, and stick the scope on the I2C bus and see what is going on both on the 3-volt side and the 5-volt side. It could well be that there is a fairly poor signal on the 3.3 volt side because the pull-ups are weak, which then means that the level shifters going through to the 5-volt side are not getting a good enough signal, so then there is a slow rise time on the 5-volt side, which is slower than is acceptable. My guess is it's some explanation like that. So, I am going to go because I have another commitment at 1 o'clock and I need to eat. And maybe you need to eat? Tradie Trev asked, can we add a beeper? I think there is one. Is there a beeper? I think I put one in. Yes, there is a beeper. I need to add that into my validation notes.
Overtime is for bodging.
I need to add that into my validation notes. Where am I? No, wrong. Once again, wrong directory, wrong machine. Not that. I'll get out of that. Where is the other terminal? Here we go. Here are my notes. Piezo beeper. That should be just a matter of driving the I/O pin in the same way that we drive the... In fact, let's do this. Let's do it. We have pin control. I've just got to reopen Fusion. Because I don't remember what the pin is. Hang on, I'm going to bring this down off here. I don't remember what the pin is for the piezo. At least this way we'll have one little bit of success for the stream. I hope. No, well, no, we had success with using Blinker for talking to the MCP 23017s. Here we go, back to Superhouse projects, Testomatic. What is the pin for the piezo? I have a vague feeling that I've just got a 3.3 volt piezo running straight off an I/O pin from the Pi. Super crude, super basic, might work, might not. What have we got? Where's a piezo? Oh, there it is. Piezo beeper. It's on IO23. Yeah, it's just connected straight to IO23, which means that if I do that, essentially, but with IO23, hang on, where is, here we go, Testomatic and I'm going to do IO23. This might make a nasty noise. Let's see. Oh, it does. Hang on. Drive low. Oh, it works. Yeah, we got a little quick win there. Okay, so now I'm going to add I'm going to add some notes in here. So I'm going to say piezo control. And that is turn on piezo. And of course, drive low. Whoops, there. Turn off piezo. Hooray! And now we can put a happiness marker against this one. There we go. We just got a quick, easy win. Don has said no headphone warning. I'm sorry. Yeah, I didn't realize it was going to be that loud. It was kind of annoyingly loud here too. All right, a little bit of progress. So, what am I going to do? Caffeine and sugar. I think those are answers to many of the questions of life. Yeah. Let's not get into that. Trady Trev says, epic, love your work, John. Well, thank you, Trady. Okay. Thank you for coming along. We had a little success. We had some ups, we had some downs. We got some answers, we have some questions. And yeah, thanks for coming and hanging out with me and getting me out of that weird sadness that I was feeling when I woke up this morning. So, some endorphins have happened and I'm feeling better. Thank you very much. And I hope you have a fantastic weekend and I will talk to you all really soon. Bye.